The tides, since they've started forming, have acted as a brake to slow the Earth's spin. You can almost think of it as the brakes on a car, pressing on the tire and causing the two to slow down together. That's what's happening and has happened from the tides.
It's a process called tidal friction.
When the tides and the continents meet, the water pushing against the land creates friction. And that friction is literally slowing the Earth down.
Gradually, over millions of years, the Earth began to spin more slowly. As a result, the days became longer and the hurricane winds subsided. It was a step in the right direction, but on its own, it wasn't enough to create the calm seas we saw fossilised in KwaZulu-Natal. The moon was still close to the Earth, its gravitational pull on the oceans still strong. For the oceans to have calmed to a gentle ripple, something major must have happened. And the answer to what did was discovered in NASA's Apollo program, the final leg of man's mission to the moon. The McDonald Observatory, USA. Here, 40 years after man first landed on the moon, the Apollo mission is still going strong. Every day, NASA engineer Jerry Wyant rides up to his laser telescope in this remote part of Texas. His mission: to measure the moon's distance from Earth.
We're the last living piece of the Apollo project. And most of the public thinks that, oh, the Apollo project's they're dead and gone. And so they're surprised when I tell them what I do, I send a laser to the moon.
When astronauts landed on the moon, they left behind the American flag and something else: reflectors. Almost daily, Jerry Wyant and his colleague aim their laser at one of the lunar reflectors. They're measuring the precise distance between the moon and the Earth.
This is a 1 billion watt laser. We direct it at the reflector on the moon, and we measure how long it takes for this light to go from here to the moon and back, and that's our data.
The laser measures the time it takes light to bounce back from the moon to a trillionth of a second. But first, they've got to find the reflector.
Each panel is about the size of this map right here. So if you think about it, we're trying to hit something this size about 240,000 miles away. It's not easy.
They need a clear night, then they need to locate the target.
Yeah, they all look alike, don't they?
Yeah, so it's easy to get lost.
It can take up to 4 hours just to find the reflector.
Well, that right there, that would be the reflector on the moon, right there.
Tonight, the laser beam takes 2.3967 seconds to travel to the moon and back.
When I see the moon in the sky, instead of thinking romantic thoughts, I think, gee, I hope the laser's working okay.
It may not be romantic, but it is amazing. Because each year, Wyant's laser beam takes a little longer to bounce back. That means each year the moon's a little further away.
One of the reasons that scientists want our data is to confirm their suspicion that the moon really is moving away from the Earth. And they've used our data to report back to us the value of that. In fact, is yes, it really is.
The moon is spinning away from us at 3.4 centimeters per year. And it's this that holds the key to understanding why the oceans calmed and life emerged. 3.5 billion years ago, the Moon was only